Johann Carl Friedrich Gauss, as German. Gauss, about this soundless in Latin. Carolus Fridericus Gauss, the 30th of April 1777 to the 23rd of February 1855, was a German mathematician and physicist who made significant contributions to many fields in mathematics and science. Sometimes referred to as the Princeps Mathematicorum, Latin for the foremost of mathematicians, and the greatest mathematician since antiquity, Gauss had an exceptional influence in many fields of mathematics and science, and is ranked among history's most influential mathematicians. Johann Carl Friedrich Gauss was born on the 30th of April 1777 in Brunswick, Braunschweig, in the Duchy of Brunswick-Wolfenbüttel, now part of Lower Saxony, Germany, to poor, working-class parents. His mother was illiterate and never recorded the date of his birth, remembering only that he had been born on a Wednesday, 8 days before the Feast of the Ascension, which occurs 39 days after Easter. Gauss later solved this puzzle about his birth date in the context of finding the date of Easter, deriving methods to compute the date in both past and future years. He was christened and confirmed in a church near the school he attended as a child. Gauss was a child prodigy. In his memorial on Gauss, Wolfgang Sartorius von Waltershausen wrote that when Gauss was barely 3 years old he corrected a math error his father made, and that when he was 7, solved an arithmetic series problem faster than anyone else in his class of 100 pupils. There are many versions of this story, with various details regarding the nature of the series, the most frequent being the classical problem of adding together all the integers from 1 to 100. See also under anecdotes below. There are many other anecdotes about his precocity while a toddler, and he made his first groundbreaking mathematical discoveries while still a teenager. He completed his magnum opus, Disquisitiones Arithmeticae, in 1798, at the age of 21, and it was published in 1801. This work was fundamental in consolidating number theory as a discipline and has shaped the field to the present day. Gauss' intellectual abilities attracted the attention of the Duke of Brunswick, who sent him to the Collegium Carolinum, now Braunschweig University of Technology, which he attended from 1792 to 1795, and to the University of Göttingen from 1795 to 1798. While at university, Gauss independently rediscovered several important theorems. His breakthrough occurred in 1796 when he showed that a regular polygon can be constructed by compass and straightedge if the number of its sides is the product of distinct Fermat primes and a power of 2. This was a major discovery in an important field of mathematics. Construction problems had occupied mathematicians since the days of the ancient Greeks, and the discovery ultimately led Gauss to choose mathematics instead of philology as a career. Gauss was so pleased with this result that he requested that a regular heptadecagon be inscribed on his tombstone. The stonemason declined, stating that the difficult construction would essentially look like a circle. The year 1796 was productive for both Gauss and number theory. He discovered a construction of the heptadecagon on the 30th of March. He further advanced modular arithmetic, greatly simplifying manipulations in number theory. On the 8th of April he became the first to prove the quadratic reciprocity law. This remarkably general law allows mathematicians to determine the solvability of any quadratic equation in modular arithmetic. The prime number theorem, conjectured on the 31st of May, gives a good understanding of how the prime numbers are distributed among the integers. Gauss remained mentally active into his old age, even while suffering from gout and general unhappiness. For example, at the age of 62, he taught himself Russian. In 1840, Gauss published his influential Dioptrische Untersuchungen, in which he gave the first systematic analysis on the formation of images under a paraxial approximation, Gaussian optics. Among his results, Gauss showed that under a paraxial approximation an optical system can be characterized by its cardinal points, and he derived the Gaussian lens formula. In 1845, he became an associated member of the Royal Institute of the Netherlands. When that became the Royal Netherlands Academy of Arts and Sciences in 1851, he joined as a foreign member. In 1854, Gauss selected the topic for Bernhard Riemann's inaugural lecture über die Hypothesen, welche der Geometrie zugrunde liegen, about the hypotheses that underlie geometry. On the way home from Riemann's lecture, Weber reported that Gauss was full of praise and excitement. He was elected as a member of the American Philosophical Society in 1853. On the 23rd of February 1855, Gauss died of a heart attack in Göttingen, then Kingdom of Hanover and now Lower Saxony. He is interred in the Albani Cemetery there. 2 people gave eulogies at his funeral. Gauss' son-in-law Heinrich Ewald, and Wolfgang Sartorius von Waltershausen, who was Gauss' close friend and biographer. Gauss' brain was preserved and was studied by Rudolf Wagner, who found its mass to be slightly above average, at 1,492 grams, 52.6 ounces, and the cerebral area equal to 219,588 square millimeters, 340.362 in 2. Highly developed convolutions were also found, which in the early 20th century were suggested as the explanation of his genius.